Oh.
Hey, Jeremy.
Sure, I'm Dennis.
Hi, Dennis. I think I've seen you on one of the programs before.
Oh, okay, all right, very nice. I think I've done enough where people start to recognize it. Awesome.
Okay, we'll start. Hello, everyone, and welcome people online as well. Thank you so much for joining us for the AIAA Los Angeles Las Vegas section meeting Saturday. Today is March 18. Today we have very interesting, exciting topic, which will continue to do more activity on this to help people network. And then we have a wonderful speaker who is very experienced in supply chain, aerospace technologies, and management as well, leadership. So we are very happy and honored to have Mr. Dennis Liang here today with us. Before that, we have a few logistics to go through. Basically, the talk plus Q&A is from 10:30 Pacific time till roughly 12. And initially, we have a panel, as you saw in the original flyer, but unfortunately, that those panels cannot make it. But Dennis might have something additional if you were interested. He actually has way much more thing he can share with you. It's not just one day. He has a lot to offer. But if you have more questions, you're welcome to stay. Maybe he can show you more. But if not, the initial design is a talk plus Q&A is like 90 minutes. But you're welcome to stay. And if Dennis would like to share more, you're welcome. And we'll continue to do, as I mentioned, this type of activity because the supply chain is a very important issue, especially with Ukraine situation and pandemic. And you don't see that, but it's happening. There's some parts and the manufacturing supply chain is a great. It's going through a very great shifting and sharpening. So it's a very good time. It's been there, but it's time we put it up some effort into this. It's very vital for AIAA and also for the community, whether aerospace or other industries. So first of all, just a few words about AIAA. AIAA is a nonprofit organization professional promoting aerospace, and we have different level of membership, and which will help your career and learning process. We have K-12, university, young professional outreach. You're welcome to join us and help. And there's no membership requirement for attending or speaking with us or volunteering occasionally, but if you're interested in more commitment or more benefit in aerospace, it's better to join the membership. Welcome to contact us. We can give you more information about it. So our speaker today, Mr. Dennis Liang, is he can tell you more about himself, but you can see this online. He's a founder of the company he's working on right now. Working with right now is Daibashi Consulting. It's a company that assists for provide ventures, government organization, and higher learning foundation with top to bottom technical and program management expertise in space-based foundation productions. So he has a wide range of knowledge and expertise and leadership. Before devoting his work full time with Daibashi Consulting, he was served as multitude roles with very diverse company from NASA, Armstrong to Northrop Grumman and the leading Fortune 500 aerospace organizations. He has more than 20 years of experience in astronautics, engineering field, and fully able to create anything impossible. So in addition to being a passionate engineer, he has been an advocate of education for next generation of engineers through outreach events at university and various other learning institutions. We'll continue to work with Dennis, and you will learn more directly from him. And you are welcome to join us better in person. You understand his passion, for helping people. So wish you can join us in person more, but online is okay. So without further ado, let's welcome Mr. Dennis Liang.
All right. Thank you, Ken. Thank you, everybody. Appreciate you coming by and giving me the opportunity to speak here on the supply chain and traceability issue. If you've been here before, you've probably seen me in a number of other talks as well. Ken did a pretty good job describing my career path. I've been in this industry for many, many different years, worked for many different companies throughout my time, about 23, 24 years in this industry. Been working from the engineer ground up all the way up to senior leadership and everything in between. What I'm going to talk about here today is supply chain and traceability as it relates to the aerospace world, specifically satellites. This one's going to be a slight twist, not so much of a global supply chain, but I'm going to concentrate on more of the internal. How does an internal company, from a programmatic standpoint, manage their supply chain issues and how it affects their decisions and how it affects everything down the line? Oh, are we having problems again? Oh, here it is again. Oh, there we go.
Okay.
Oh, did you do it or I did it? Okay.
I didn't do anything.
Okay. So as we talked about, what exactly is supply chain? General term, all right, applies across many, many different industries. What exactly is it? It's pretty much every single piece of material that's required to build a product and how it flows and gets to the prime contractor, how it gets installed, and then how it gets finally delivered to the customer and launched. Even after it goes off, if there's any issues on orbit, we still have to go back and find things like such as what happened, why did it happen. If it relates back down to a specific part, we've got to be able to trace it all down. So in a nutshell, that's really what we're going to be concentrating on from a supply chain standpoint. So supply chain and traceability go hand in hand, right? If you can't find out where the part came from, you really cannot find the root cause of what the issue really is. And I'll give you some examples as we talk through some real life examples of things that have happened throughout the years that I've been working, and you can see the ramifications of traceability and how critical it really is, right? And when we talk about traceability, it's not so much the traceability of company to company, but it's also within the company, how the part was manufactured. Where did the raw materials come back? Literally as far back as you can potentially go that could impact the product, that's how far we have to go back. So traceability can have disastrous effects if you don't know what the issue really is. So when we buy a part and we ask specific suppliers, hey, do you have this part? There's a number of things that we look at, right? And we'll talk about that as well. But we also want to know, can you be able to work within our processes? Meaning that we impart a lot of things on our suppliers, such as, are you certified? Do you have traceability? Are you ISO 9000 certified? So on and so forth, right? And these companies have to be able to meet those requirements because, again, one thing such as buying raw materials that were bad, manufactured, say a bolt, and then that bolt cracks or whatnot down the line, then you could have a complete failure of something, right? And so how do we find out where things are? So in the aerospace industry, you'll hear that nothing gets done without paperwork. And that paperwork is your traceability. And all of that information is a deliverable to our customer, which is why we do a lot of these different things. You'll have proper documentation, part numbers, data, revision, all this kind of stuff is all recorded in there. every once in a while, you get what we call guide up alerts from the government. And these are industry alerts to say, hey, maybe a different industry, this one supplier supplied something bad. And then that part goes to many different industries and you'll get an alert. Say, hey, do you have this part? And I'll give you an example. We've gotten guide up alerts about particular titanium fasteners. And they asked, okay, well, did you use this part? Yes, we use this part. Now, here's the question. I have thousands of titanium fasteners on this thing with many different lot numbers from many different, suppliers. So where is it? This is where you start drilling down. Where did we buy it? When did it come in? Which parts are in warehouse? Which ones on the floor? Which ones are on the vehicle? And so how do we know all this? There's documentations from our supply chain group. And then there's also documentations from our engineering group. You have to start piecing them together. When was it delivered? When was it installed, right? And so on and so forth. And where is it installed? And so this is where the paper traceability comes in to understand what's going on. Because we don't just buy from one supplier. And we have warehouses with thousands upon thousands and thousands of bags of different bolts. And they could be different lot numbers. They could be different suppliers. They could come in from different times. And so we have to be able to go back and really look at all these things and where it really came from. Program risk in terms of traceability is we've had issues where a part comes in, we've had a failure, and we stopped because we couldn't go any further. We didn't know where it came from. And when I say we didn't know where it came from, is we know where it came from in terms of the manufacturer, but our paperwork was a little lax for this one particular part where we did not have the lot number. And so we had to search for the lot number, right? Because we didn't know what it was. And so that's why paperwork and correct information is paramount to how we maintain the quality of our products in the aerospace world. And in this aerospace world, if you can imagine, if you take the James Webb Space Telescope, $9 to $10 billion, you could have one failed bolt, and that could torpedo the whole mission. So you're talking about a $90 bolt can destroy a $9 billion mission. And so that's why it's extremely important to us of paperwork, traceability, and the supply chain. So you can see here, this is just a really top level overview of how the such supply chain world kind of works in this aerospace industry. You got your typical prime contractor here who's building the main product. And then you have your domestic suppliers, right? Companies like Moog and whatnot who supply other subsystems or parts or components that deliver to the prime. Well, they also have their suppliers. And then these are, more component raw materials suppliers that kind of tier up as you kind of go to the prime contractor. But then you also have international. International in itself, has another breed of problems that we try not to deal with if we don't have to, because it is more complicated dealing with international suppliers. We have the customer over here. Now, the customer sometimes does provide their parts and or payloads to the prime. Not all the time, but some do. Some larger customers do, such as if you're working with NASA, like James Webb, right? The mirror and all that was provided by them. And so they may provide a payload here and there and or parts. So there's a different way of how we deal with customers in terms of traceability. Sometimes it's easier, sometimes not so much. And I'll go into that a little bit more. And then you also have your own internal suppliers. So if you're a vertically integrated company, like take, for example, Northrop Grumman is a vertical integrated company. And for those who are not familiar, when I say vertical integration, is you're talking about a company that can actually build every single part in a specific vehicle if they wanted to in their factory, but they don't because of cost constraints or availability. So then they go outside and they buy it. So we have to look at the internal supply chain as well. Things that within the prime contractor, they build themselves, they manufacture, and then they deliver. So we're going to talk about the internal. I mentioned this before, early decisions affect your overall supply chain and how your program is really going to be managed. When we sit down in a proposal phase and we start thinking about, okay, what is this mission going to do? Where are we going to buy these parts? Where is it going to come from? How is it going to work within our architecture and our design? Supply chain is absolutely critical for the decision that has to be made. Now, give you an example, say you have an electronic box. There's a company outside that makes that electronic box. We make our own electronic box internally as a prime. Then you start doing your trade-off. Hey, what's the point of going outside versus inside? Cost, delivery time, management time, right? So you start going through all these quality to see, which is really the best trade-off. Because if you don't get it right in the very beginning, you might be inducing more risk down the line in terms of quality and or availability of management. But if you build it in-house, generally when you build things in-house, it costs you more. So again, that's another risk that you're going to have to trade off from a management standpoint. Hey, do we make the items? Do we buy it off the shelf, right? So on and so forth. COTS and make items is most definitely going to be, it's a topic that's been around for, I would probably say, really come up to the forefront probably was in the last 8 years. Do we buy whatever is available out there, or do we make the items ourselves? All right. Now, the reason I say the last 8 years is because with the big influx of CubeSats, most of these CubeSats are going to be more this right here because of cost and availability, right? These make items are going to be more for like these flagship vehicles like the James Webb or any other kind of flagship satellite vehicle, because these are going to be, you're going to need 7, 10, 12 years kind of lifetime, on these parts. So you're going to have to build specific things in there, such as radiation hardening and so on and so forth. And those are the kind of things that generally you don't necessarily get here. And if you do, the price of this is starting to approach the make items themselves, right? Because there's a lot of testing, there's a lot of regulations and requirements that's involved in it. So these are some of the considerations that you have to worry about. And then the supplier, we look at the different capabilities of the supplier at the very upfront view. Talked about before, what is their capability? What is their reputation? And are they even available to even provide this product that we're looking for? I'll give you an example too at the next level. If you're a customer, and this has happened to us before, is that if you have big flagship vehicles that you want to build, they're only going to allow it to be bid to a couple of suppliers, right? Namely the big three, right? Boeing, Lockheed, or Northrop Grumman, because they know that you have the capability, you have the reputation and availability to do this. They're not going to farm it out to a small set company. They don't even have the facility. And so this is the things that we have to look at from a piece part and subsystem level as well, is what is their capability and reputation, right? For example, some companies are known to cost more than others. And so that goes into their determination of, do we want to go with that person? And one of those things that you have to look at as well is, you can kind of figure Northrop is known as one of the more expensive companies. And the reason I say it's known as one of the more expensive companies because they are a vertical integration company, right? Meaning that when they look at capability, they can buy a box, come over here to this facility, and if something were to be wrong or there's a failure in that box, they know that that company has the capability to fix that box at their facility. They can take it apart, they can resolder the boards because they do that there. So they have that capability. So that's where maybe the cost outweighs the risk of the financial part. And so that's where you have to go through all that whole trade. And then of course, availability. Availability, I mean, has been a big talk over the last couple of years with the pandemic. And there's wars in the areas, how do we get these parts to us now? And so availability has really been thrust into the forefront lately. It has always been a part of our decision, meaning we typically don't want to buy parts too far away unless it's absolutely necessary and or required by our customer. Because as the government has requirements that we have to work with certain suppliers and so on and so forth. But if it's not, then we prefer to stay within our area. And reason being is, I'll give you an example. If we're building a product on the floor and let's just say we ran out of bolts. Bolts broke, we couldn't find some, whatever the reason is. We would rather have a person drive down to a local supplier and get it to us within an hour versus having to fly across the country and get it, or have them come over or ship it to us overnight. Every single hour to us is a lot of money when we're building these vehicles, right? To us, every day, depending on the size of the vehicle, could be hundreds of thousands of dollars of delay, if it's that big of a delay. In a month time frame, you're talking millions of dollars. So that's why we would prefer to keep our supply chain as close as possible, where if we needed to get something, we're able to get it quickly. And those are things that we have to look at. So let's look at the different types of suppliers. There's different tiers in terms of what their capabilities are. There's tier 1, tier 2, and tier 3. Generally, the prime contractor is categorized as a tier 1, and by default, because they're building the overall system. So you're talking major components, big items, final flight worthy qualified parts. These are generally your tier 1s, and they're the ones that go around and bid on these big flagship programs, multi-build satellite programs. So they're generally the tier 1s. The tier 2 is the next level that supply up to the tier 1. So you're talking about sub-assemblies, electronic boxes, and so on and so forth. So they're kind of like the next level. Tier 3, they're more component manufacturer, nuts, bolts, electronic harness, and so on and so forth. So they're more of the component level, and supplies up to tier 2 or tier 1, because again, there are certain tier 1 companies that can actually manufacture their own parts, so that they will buy components from tier 3 themselves into the tier 1 level. So it's not necessarily 3 to 2 and then 2 to 1. Depends on what each level's capabilities are. And then, as you can see here, where we've talked about the international portion, when we get to international, there's this right here, ITAR and export rules in the aerospace world, that adds another layer of complexity to what we need. There's times where you just can't get away from the international, such as these big flagship programs, like from NASA, that has many different customers and many different stakeholders from across the world. Then you have to work with them, right? But in general, we try to stay away from international suppliers because of availability, because of the additional headaches that might be brewing here. It's sad to say too, politics does come into play. I don't like you, you did something to me, trade war happens, and then here we go, we got problems again, right? And so we want to try to minimize that as much as possible. And so we're going to go through each one of those and the considerations and implications for each internal, external, international, and also our customer. So internally, if you're a company that's able to build your components, your subsystems, your payload, and the overall vehicle itself, there's a lot to be said with that. You can control your own destiny in a way, right? Where internally you can control your schedule, you can control your costs, you control your availability, you can rearrange the schedule however the executives want to do. So you have that ability and faster turnaround. But there's a cost to that, and that's the financial part. It does generally cost more when you build internally. So then a lot of people look externally. Even a lot of these prime contractors look externally because there are a lot of good companies outside that produce products that are space qualified that many companies have used over the years. So there really isn't any reason to not consider external companies unless, like I said, there's a specific availability and or quality where only certain people can build. But when you go outside to a different company, there's a lot of different rules now that we have to impose to ensure quality, financial cost oversight, and delivery now, right? So let's look at quality-wise. How do we ensure that the part that we're getting is going to be what we really need and is going to fit? So we impart a lot of controls such as source control drawings. We do a lot of inspections on site. We also have our engineers, not just quality people, but engineers go over there and have constant meetings with them depending on the criticality of the product. If they're building a payload, we try to provide more oversight and understand what they're doing at more steps of the way. If they're providing a component, we kind of just give them the source control drawing and maybe do a quality check every once in a while, or maybe at time of delivery. And the problems with this is if you don't do this, I'll give you an example where a company provided a big payload to us, and this was an instrument payload. It's about, I want to say 600 pounds, pretty big, 4 foot by 4 foot by 4 foot cube. And when they came to us and they gave us the template, the mounting template did not match our vehicle. So we're sitting there like, oh my goodness, what is this going to cost us, right? We can't mount that thing onto our vehicle. The beauty of that is that the template was wrong, but it was built correctly to our drawings. So crisis averted. We matched it up and we're like, hey, your template doesn't even match your mounting locations, on your product. And so that's why source control drawings and, try to get ahead of these issues before it gets down the line. Once it gets down the line and delivered and ready for installation, it's absolutely way too late. And at that point, everything costs 10 times the amount than if you caught it early on. And so that's part of the external implications here. Equipment and consumables. And I'll talk about equipments and consumables kind of spotted throughout this presentation, is that things that are provided by a different vendor, consumables that are provided by a different vendor is not necessarily easily usable, especially if you had extras or if you had a piece of equipment that you want to use again, because there could be documentation issue, who owns it, you have to transfer ownership. If you damaged it and you didn't transfer ownership, who pays for it, right? And so there's a lot of different kind of liability issues as well when you do external versus internal, right? If the company owns it and you broke it, just get an approval and so on and so forth. Somebody fix it and we move on. External, some additional implications. And of course, delivery times and schedule risk involved. As we've seen, with this latest pandemic, it becomes very difficult, especially if you are time sensitive, right? And you own these things and you need it here ASAP, but they don't have a delivery mechanism available, and or to them, you're not important, right? And you'll see this as a recurring theme throughout, is that if you are not a big enough customer, you are going to be relegated down the line. And so that is going to be an absolute decision factor on whether or not we use a particular manufacturer. Because if you're just buying 700 bolts when they provide these to the automotive industry that buys it by the millions, you are absolutely going to be at the bottom of the line. Even though it's critical to you, it's not critical to them. And so that's these decisions that has to come in here, is what's the schedule risk and delivery times involved, right? If you're their biggest customer, no problem. They're going to bend over backwards to supply you. But if you're not, you got to really think hard about this, right? So international considerations, and we talked about this. There's a lot of ITAR and export control rules involved here. There's a lot of companies that we cannot work with, whether they're from China, Russia, or whatnot. But there's a number of different things that companies that we can't work with due to security concerns. And there's also these same countries and or companies that we cannot provide products to because of these same issues. And you'll see a lot of that in the news lately, you know, with bans on specific software and or hardware from companies from like China or Russia and so on and so forth. And so we have to be very cognizant with this. Luckily in the aerospace world, this is extremely limited because of the sensitive nature of what we do. But there, like I said, there are times where if you're working with NASA, works internationally. So they've got a lot of people around the world that they work with, and we have to be very cognizant of this. There's also a lot of additional implications for like delivery of materials and consumables. I remember on one program, there was 5 payload suppliers from all over the world. A couple of them were from Europe, the Netherlands, you know, Japan, and so on and so forth. And I remember having to get up and start meetings at 4 a.m. in the morning because to them it's 6:30 p.m. And so we're setting these coordination meetings every day for months on end to make sure they understand what can you bring inside the United States? Do you have your documentation ready for import-export controls, ITAR? Do you have, what is your consumables and your materials? Because what may be okay for them may be an absolutely no for this country, and so on and so forth. You look at the food industry, right? FDA approves certain things here, banned at other countries. And so that's why we have to be very cognizant of those kind of things when we go from an international aspect and we start bringing these people over. And then we also have to look at their particular process and process control. They may be okay with having a plastic frame with a plastic bag on top of a unit. And that's okay if the unit is completely sealed, right? Faraday cage, okay. But if the unit is not completely done yet and it needs to be finished at the prime contractor, that means it's partially open. And so they deliver it with a plastic frame, with a plastic bag. True example, we looked at it, we're like, we're not going to touch that because we're going to create static electricity and we might fry that whole unit. So we're like, we're going to let you guys touch that. If you need any support, you let us know, right? So there's a liability aspect. And so that's why it's very important to really know what they're doing and what they're bringing over. I'll give you another example too as well. We bought a star tracker unit from a company called Galileo in Italy. And this is where they use metric. We do not. We use the US units. And so one of the bolts was stripped and failed. And we could not find an equivalent metric bolt here. So what do we have to do? We had to call them back and they had to overnight one little bolt, which was probably around $10, all the way from Italy. And so we lost days just for that little bolt. I had people scrounge the entire US to try to look for a bolt, that same spot, and we couldn't find it. So we're like, okay, forget it. Just get Galileo, send it over to us ASAP. And so that's part of the reason why we try to stay internally or domestically if we possibly can. Now the customer considerations, this one is kind of odd. Doesn't happen very often, but it does happen. If you have a big customer, such as say you take NASA Goddard, big customer in the world, they know everything. They know how to build satellites and they know how to build space products. They have their own managers and so on and so forth. They build their own flagship programs. And so now your customer is providing you a product. So you got to be a little bit cognizant that they are your customer and also your supplier. So you got to tiptoe a little bit on how you deal with them, right? You can't heavy hand them sometimes, even though when they're behind. So you're going to have to be, hey, you know, it's a dual program at that point almost, where you have to work with them, you know, hey, coworker, instead of supplier, how do we work together to bring this in? And so that there's a little difficulty there, but it's not impossible. The positive is that your programs are in sync. They know why they're delivering it, and they know that if they don't deliver to you, they are the cause. So you don't have to prove to them that they're the cause. They already know it. And so they're like, okay, we take the blame for it, right? Suppliers will fight you on that constantly. And so this is where it makes it sometimes easier to work with them. So there's pros and cons. Much easier to share hardware and consumables between, because the customer already knows they gave you a lot of the requirements, so that you guys are really using similar types of consumables and materials. And plus, if they wanted to be able to share, say, a non-flight hardware with another NASA program, because they're NASA internally, again, it's very easy for them to say, yes, you know, sign the paperwork, fill it out, go ahead, they can use it and borrow it, or transfer it to them if you don't need it anymore. Transportation and infrastructure, same kind of thing, where not necessarily internal, but a customer with the prime, you can kind of consider as almost like an internal, where you guys are all on the same page. Transportation becomes easier. They're able to loan you transportation containers from another program that they had, versus you having to build one, so on and so forth. So there are pros and cons to each one of these, as you've seen. So technology. So I love technology, but aerospace companies in general has been very slow to adopt technologies that the retail world has been wholeheartedly embracing quickly, because to them, every minute counts, every customer counts, every second counts from a profit standpoint. The years passed, and it has been changing in the last couple of years in these aerospace world is, hey, we've got the big bucks, government, doesn't matter. We just charge them for whatever it takes. So we don't need new technology. We'll just keep the way we're been doing. We just charge them. We just overrun, and so on and so forth. Well, there's been a big change now. The government's gotten wise. The purse strings have tightened. And so now it's, hey, fixed price. You bid for this, that's all we're going to pay you. You run over, that's on you. And so now we have to start leveraging what other industries have been doing, right? I take, for example, let's just take something that's been around for many, many years, RFID, right? RFID tracking has been around for many, many years, right? In and out of the warehouse. No one has to click anything. No one has to pass through a center. I know how many went out. I know where it went. I know how much came in, so on and so forth. The way a lot of our companies do it now still requires an army of people to get it, tag it, inventory it, put it on a piece of paper, input it into the computer. And so you can see there's a lot of single point manual failures, where if a person didn't do their job, you just lost track of everything. And so we want to start implementing a lot of these technologies, not so much even in a warehouse perspective, but even on the floor from a delivery perspective. Now, I know like these high production companies like the automotive world, they've got this down pat, right? But the aerospace world, where, you know, to us, building 20 is high capacity. It's you know, big production run, right? To us, we have to be a little bit better in terms of how we utilize this technology. Give you some examples too, is the left hand doesn't know what the right hand is doing, right? You're within one company and you order the same stuff, say a particular adhesive, and then this adhesive could cost $5,000 for an ounce. I mean, for a quart, right? $5,000 for a quart. This is very expensive stuff. So $5,000 for a quart, but This program only needs an ounce or less. They don't need the rest. And there's a shelf life. So then it gets trashed. Well, guess what? There's 15 other groups that bought the same thing. So 15 groups times 5,000 that just bought the same thing, and they all need an ounce or less. And no one talks to each other because no one knows who needs what was bought, and so on and so forth. And so what happens is you start to have a lot of redundancy, right? You have a lot of waste. And so when you have technologies that increases transparency, and it could be something as simple as a screen in the supply chain room saying, hey, we just ordered all these parts. Do we really need all of them? Do we need all these consumables? Because, you know, we only need an ounce, but this is minimum buy. We only need this one. This is minimum buy. Can we combine them all together? Maybe get a bulk buy discount. It could be as simple as just a screen on a wall, but we don't know because right now it's on a spreadsheet in somebody's computer and or in a complicated system like SAP that only one person knows how to operate, right? And so we have to be more transparent and have this technology out there. I always like to go back to the airlines and the airports, where when you walk through the airports and you see the screens of your flight, your gate, the time and delay, right? But behind the screen, there's just, you know, trillions and trillions of bytes of data that you just don't need. I just need to show you what you need, that particular person, and get them on their way, right? So you show the supply chain guys what they need, you show the engineers what they need, you show the technicians what they need, and then they're all interconnected with one another, and then you have a more seamless and integrated system. And all of that tied back to the warehouse, and then all of that tied back to the buyers, and so on and so forth. And then you become a little bit more efficient along the way. Part of the reason why we were pushing really hard on this technology portion is, in the aerospace world, we have a lot of things what we call go finds. I don't know if you guys are familiar with that, where we are accountable for just about everything that comes into our factory, whether we own it or not, right? From a cost and auditing perspective from our customer. And I'll tell you this right now, if you have a very large program like James Webb, we lose hundreds of items all the time. And so when there's an audit, so what do? I send out teams of, 20, 30, 40 people. Here's a list of 800 items that we cannot find and account for, and the total value of it, $50, $60 million easily, right? Go find it. We got to account for it. And so every 6 months, every year, we go out and we find these things. Once we find it, 2 years later, guarantee you we'll probably lose about half of them again, right? Very manual based, okay? If we have RFID or some kind of technology, it does make it easier, but that's not the end all be all, because in the aerospace world, there is classified portions where RFID is very frowned upon, right? Because it could transmit information. But we work with them where they're starting to understand the idea of passive versus active RFID. And so then they're starting to realize, okay, maybe we will allow passive RFIDs versus active ones, right, to help track our information a little bit better. So when you do introduce technology into aerospace world, you do have to take into account the classified nature of most of these programs, right? I'll give you another example too, such as like Wi-Fi. Wi-Fi to us, yeah, okay, everybody has Wi-Fi. But in a classified world, you even say Wi-Fi and they'll kick you out of the building, right? Wi-Fi, even outside the building, cannot be within certain feet of the common wall. And so there's a lot of rules that, that's applied to the technology portion. Now, that's not to say that the technology cannot be reworked to work that way. It's just that the companies and the technology companies and the customer and their security portion of it has to sit down and really go through every single aspect of it and really dig down and say yes or no, rather than just a knee-jerk reaction of, oh, technology, absolutely not, right? Because we've done this over the years and it works just fine. So there's a lot of growing pains especially with the way that technology has been growing so fast in the last 20 years, is that a lot of these companies and the customer will just have to really sit down and really take a look at what can really help reduce the cost of your program, because again, the purse strings have been tightened by the customer. And so there's a good and bad to that tightening, is that people are starting to look at, okay, technology can be one way for us to maintain our processes, but make it more efficient rather than hiring too many different people just to do mundane tasks. So that's the technology aspect. We talked about this as well too, the internal supply chain management. In the aerospace world, there's a lot of different layers of supply chain. This one right here, when I say internal, it could be internal within the company, it could be internal within the manufacturing group, or it could be internal within the integration group. So you can break down, what internal supply chain management means. A lot of the problems that we've been having lately, like I've talked before, is that internal supply chain management, there's a false sense of security. We know what we're doing. We've got it. We can handle it ourselves, right? When you have somebody else external, I don't trust you as far as I can throw you, regardless of your reputation. That's just the human nature aspect of our business, right? So internal, there's a false sense. I've got it, not a problem. And so if you brought in a person from the outside and you really look at what they're doing, you're like, this is chaos. This is managed chaos. And so there's better ways to do it, right? So like we talked before, lack of transparency. I don't know what the left hand is buying. I don't know what the right hand is buying. We're buying duplicate. We're wasting all this stuff, right? I could buy a minimum roll of flight-worthy aluminum tape on this side, where I have to buy 50 rolls of it. I only use 10. This guy buys another 50 and they only use 20. Combine the two, but they don't know it because they don't talk to each other. Each individual group has their own little fiefdom, right? Don't come into my area. I won't come into yours. We take care of ourselves. And then so who ultimately pays? Corporate ultimately pays, right? The programs cost too much. Then when the programs cost too much, you become having this reputation of your company costs too much. And so what happens then is that now you're graded lower when it comes to awarding of programs. You cost too much, right? And so there's ramifications from bottom all the way to the top. Let's see, next one. Non-flight for flight testing. So this is another aspect of the supply chain world in the aerospace industry. Is there's engineering units and then there's flight units. But if you really look at it from how it was built, it's built exactly the same. There really is no difference. The only difference is whether or not it was qualified for flight or it was qualified as an engineering unit. These engineering units we use for testing because we don't want to overexert the flight units if we don't have to. And so in the satellite industry, we usually have what we call test beds. And these test beds are an exact replica of the satellite electronics, but on a flat table. So every electronic unit, every harness, every cable is identical in terms of production, quality, material, and length of the flight vehicle, so that we can troubleshoot on this and not damage the flight one, because the flight units and engineering units have cycle time limits on it, right? You can cycle it so many times before, quote unquote, you run out of its useful life. And so what do we do for non-flight and flight? We have to track every engineering unit to the T as though it was flight. And the reason being is that, and it happens quite often, is that if a unit fails on the flight unit, and that flight unit is a one-of-a-kind build, the only spare you have is sitting right there. And so what they're going to do is they're going to take that one, they're going to quickly qualify it back to flight, and you need to have all that traceability, because if you don't, it's going to take a lot longer. So what they want to do is they want to qualify that, replace it, take that failed unit and go get it fixed, and then replace that one as the engineering unit. Okay, they're going to swap them out, right? Because there's no time to build a new one, because a new one could take a year to build, another $5 million. There's just no time to do that. And so that's why engineering units, quote unquote, non-flight engineering units, we treat them like flight. Traceability, supply chain, documentation, everything is treated as though it's flight, because more than likely it can be used as flight, because these are considered backups. So one of the final aspects here from supply chain is what we call closeouts at the end of a program. When we close out a program, we have warehouses and factories full of stuff, half used, never used, you know, stuff just lying around. And there's ownership everywhere. Some programs own it, some external companies own it, some parts internally owned, hardware, flight hardware spares, support equipment, test racks, just runs the whole gamut, right? And so what do we do with it? Generally, we either what we call abandon in place. The customer says, I don't want it anymore, do with it as you will. If it's still good, we might use it. Other one is return it to the customer, transfer it to another program, perhaps, right? A lot of documentation involved. People want to see what happened to it before, where is it still in good condition? It's akin to you buying something from eBay, right? That's been used. You want to know where it is, you want to know the quality of it, you want to know as much information as possible. And so this is where the traceability and the supply chain part comes in and say, hey, this is what happened to it, this is how many revisions it's gone through, we have all the documentation, it's been approved, and so on and so forth. Awesome. We'll buy it off of you, transfer the cost over, we'll take it, right? So then these closeouts is going down every single one of flight items, what's remaining, can we reuse it? If not, we trash it. How do we trash it properly, right? So let's talk about that real quick. So a lot of the stuff that we use is hazardous material, whether it's adhesives or bonding or even the materials itself. Like if parts have beryllium, pretty nasty stuff. You don't want to touch it, with your bare hands. And you can't just dump it out and, call a what do you call it? One of those, scrap heaps. Hey, come by and grab it for $1 a pound. Can't do that, right? And so we have to make sure we dispose of it properly and so on and so forth. And we have to prove that we disposed of it properly. I give you another example. So many, many years ago, I would say this was probably back in the maybe 80s when I was managing one of the engineering groups over there, and we were looking at expanding our facility. There's this little area in the back of our building, and we didn't realize what was in there. And I wanted to get rid of it and expand. Guess what was in there? Radioactive material. So like, wow, fantastic. And it's been sitting in there for probably 35 years. Like, well, great. I'm sure the rules were more lax 35 years ago, but I can't even walk up to it now, right? In today's world. So they didn't dispose of it then. So we looked at how do we dispose of it? Oh my goodness, trying to dispose of some low-level radioactive material. It was going to take 2 weeks and about $5 million to transport 50 gallons of this low-level material out. Oh my goodness. And so because it wasn't done before, you're paying 10 times the amount later on to deal with it, right? Because it's something specific. And the only reason they left it here was that, back then we were quote unquote grandfathered in to be able to deal with this stuff. So it becomes very important. If you leave it here, again, recurring theme, you leave it for somebody else, it costs 10 times the amount later on down the line. So you have to understand what it is and how to get rid of it quickly. And by doing that, you need the the traceability and all the supply chain paperwork, because the customer, not the customer, but the city and the transportation company asked, what is it? How much is it? How long has it been sitting there? How long has the bottle's been there, right? Because they don't want the bottles to be corroding internally and then it leaks during transport. And so what happened? We didn't have any of that information because this is 35, 40 years ago. It's probably all lost in paperwork. And so we were trying to sit there, trying to work with them. You know, we spent months upon months upon months trying to prove to them it's okay. And so if we had all that documentation, here you go, here's the bill, yes or no, we would have been done within a week, right? Closeouts as well is, what do we provide to our customer, right? There's a lot of deliverables that we have to give to our customer from a traceability standpoint. Not just how does parts get from producer to prime contractor and then onto the vehicle, but it's also flight information. What was installed, what was not installed, how many revisions did it go through, right? What drawings did you use, all the requirements validation, all that documentation has to be part of the supply chain of that vehicle given to the customer. For example, I was in a control room for a launch and they launched it. A couple of hours later, you know, they were starting to actuate, turn on power. They had an anomaly. Like this is not moving. This arm is not moving. So me being one of two mechanical guys standing in the back room, the whole room turns around and looks at us. Let me get back to you. I got to go back to the paperwork, what exactly it was, who installed it, how it was installed, what part, and so on. So we had to trace it all the way back. Luckily, while I was doing that, they were tracing from an electrical standpoint if there was any kind of anomaly there. Luckily, it was an electrical anomaly. But if I did not have that paperwork and be able to prove to the customer that I did not accidentally bind it up with, say, MLI, right, because of, you know, poor installation on our part, then it's okay. If I didn't, then the customer will always have that lingering expectation that you could have done something wrong mechanically if they didn't find the issue electrically, right? And so that right there could reduce the mission life. And so that's why, like, documentation is very important. They'll want to, we've traced all the way back to a specific bolt made by a specific manufacturer with a specific lot on a specific date, right? We've gone all the way back, as far back as that. One more example on this, but this was during the build, was that we got, I had an alert from internally that one of the torque wrenches that we used was out of calibration. So when I got that alert, I'm like, are you kidding me? We use that torque wrench everywhere, all over our vehicle. Right? So now the question being is, we had two main torque wrenches that we used, that our technicians used. What was used on what? Either take the whole thing apart and retorque everything, or prove to the customer that only these were done and we will retighten these, or we will only check these and not have to redo everything. Right? We went back in our paperwork. Lucky our paperwork included every bolt that was installed, along with the torque wrench and calibration date and part number of that wrench for every installation. So we could go back and say, okay, these 600 steps was the only ones that used this torque wrench. The other ones were the good torque wrench, right? So then we can go through all of that and prove to the customer, hey, if you want us to take apart, we could take a look at these and fix these and not do the whole thing, right? It saves you a lot of headache down the line. Not only that, but it adds to your credibility and reputation that, hey, we've got our stuff in order and we're able to answer any question that you have, and that any anomaly, we can trace it all the way back. So that reputation follows on to the next program. Hey, I remember these guys. They traced everything all the way back. They were awesome, great. That adds to your potential for award for the next program as well. So when I talk about this whole supply chain, I know this is really top level, but I want people to know that it's not just the nuts and bolts and how do I get a part onto a vehicle. I want people to understand that this is reputational as well, your credibility for whether or not you can build another program with this customer, because they're going to sit here like they torpedoed my project for one bolt. They're never going to come back to you again, right? And so I want people to understand that supply chain has large ramifications beyond just the initial cost, program management, risk of schedule, and so on and so forth, but it's reputational. It's also, you know, how easy is your program going to be? It's going to be how easy is your relationships going to be with your suppliers and your customer going on? Because if you can't prove these things, your customer and program relationship is going to be very strained and contentious going forward. You're going to have to prove everything to them from that point on, right? You've destroyed the trust. And so I want everybody here to understand is that supply chain management, everybody understands from a, you know, typical, it needs to get at this time, who needs to supply it, I need to have documentation, but think a little bit beyond of your customer relationships and how it might impact your future program awards and your reputation, right, in this industry. Actually, in any industry, if you really look at it across the board. I think that's it. Yeah, I think that's it.
Okay.
So, any questions that I could potentially answer for you? I know this is really just top level, but yes.
You think, because you talked about how like a lot of materials go to waste because one department doesn't know what another one's doing. Do you think maybe they'll get like maybe like some AI systems or something that can streamline that down?
Yes. So there is a lot of, so before I answer your question, I'll give you an example. There's a lot of AI systems now, I guess predictive management from, let's say, a facility standpoint. Let's talk about facilities real quick first, where, you know, they look at, you know, your air conditioning units and so on and so forth. And they'll be like, oh, okay, hey, it's been 6 months, you know, let's put up an alert saying, hey, it's ready for, you know, a whatever kind of a review and so on and so forth, you know, maintenance and predictive maintenance, preventative maintenance, whatever you want to call it. And that is something that could be easily transitioned to a supply chain management, where if, for example, you plug in enough information in the front end in terms of when you need it, how much you need, it could provide alerts to you, say, hey, you know what, we're coming up to the schedule time. Is it ready to order these things, right? Now, schedule changes all the time, and that's not to say you can't say yes, no, or plug in a new date where it, you know, hey, it dumps back out. Now, SAP does have that kind of functionality to allow you to do that kind of stuff, right? So it's very kind of rudimentary, right now, in terms of, I guess, a predictive analysis of when you need parts and how you can potentially reduce waste, such as, I'm not sure if the software right now is smart enough to say, hey, this one is minimum by a quart, I only need an ounce. And if it sees 10 different people from the same organization ordering the same thing, whether or not it can dump out something saying, hey, maybe you only need to order 3 instead of 15, you know, quarts, right? I don't know if the system is smart enough to do that, right? But that's not to say that's just a matter of programming in, right? So I would say they're working toward that right now in terms of predictive. Automotive companies are a lot better at that, right? Because they're such high production, and so they're better at predicting when they need. For lower end from the aerospace world, where we're not moving at such a quick pace as some of these other industries are, it's probably easier to do that predictive analysis. but the difficulty is going to be is that there probably will be a lot of changes in the schedule, right? And so you have to be able, so the system has to be able to adjust quickly to all these changes, because you can move to the right and then all of a sudden move back to the left, and you could be back and forth within a week, right? Determining on when you need that part because maybe something is broken. And so these systems has to be designed to be very robust in the aerospace world to be able to handle these kind of ups and downs in terms of schedule. So I think it'll eventually get there. Yes.
Kind of building on that technology question as well. You mentioned like SAP and spreadsheets bearing the brunt of all of this workflow. What other tools and technologies is aerospace adopting or has adopted to kind of manage this organized chaos?
So a lot of them are looking at RFID right now. I'll give you an example. So over at Norfolk, before I left, I was tasked with building a new production factory, a high-tech production factory. And that includes bringing in brand new technology throughout to help efficiency. And so one of the areas was really the warehouse and supply chain portion of it, what we call the harbor management and planning and logistics group, right? And we were looking at a number of different technologies out there. My view is, and especially these companies, is that let's not reinvent the wheel, because that's not our forte, that's not our business, right? We want to buy something out there that we can integrate quickly and doesn't cost that much money. That's the quickest way you're going to get adoption from these companies and money from the executives, right? And so what we did was we went out and we looked at, okay, digital signage, right? From the airport. Oh, what do we have? Where is it, right? This kind of information is easily accessible. Everybody has it. That's something that we can easily integrate in here, right? So we can bring that in. RFID, again, everybody has it. We can bring that in here. Now we have to modify those a little bit, as we talked about before, but we can bring those in there. Now, the biggest problem is, how do you get each one of those systems who are meant to work individually work together? Now, that's the key.
Like to work back to your ERP.
Yes. Now, that's the key, is that link is, you got digital signage. Maybe you have augmented and virtual reality systems on the floor that says, hey, I installed these things. How do you get all that information back from these individual systems to tie into one single system that goes back to your legacy system, right? Because a lot of these people do not have the time or the cost or the money to redo their entire legacy system, right? And so they want something that's able to connect seamlessly, or at least connect easily, right, to their legacy system. Because if you go up to an executive and you go, well, it's going to cost 3 years and $15 million, right? Wall just went down, and you might as well just get up and leave at that point. They don't want to hear you anymore, regardless of how great your system is, right? As soon as they hear that, forget it, not worth it. And we've had that many, many different times. So before I started this factory, we changed our approach to how we pitched it and how we worked at it, where we did it, from a phased approach. What was our biggest heavy hitters? And we started saying, okay, well, we want to eliminate these go fines, and it's at the warehouse. Well, most of the warehouse is not classified, so maybe we can easily implement, RFID and these things. So let's take it as a phased approach, and then as we're working in a phased approach standpoint, we can start figuring out how to link them together and create a story. So these phased approaches are essentially like getting your foot in the door and grabbing a hold, so that they can't live without it. And then, hey, let's combine all these together into one system, right? So there's a lot of different technologies out there that could be used. Like I said before, digital signage, RFID, we used to have hand scanners, and now we went away from hand scanners to just, barcode, just walk by and just, optical barcode versus a handheld one. You just put it on there. And then we were actually even looking at augmented reality, where, you have a headset on or something, and I installed this part. Now, how do we get that data back, right? So things are moving really quick, And it's really up to either new startups or other companies to really figure out how do you integrate the new with the legacy. That's going to be your biggest hurdle, is the new to the legacy. And that's the story you're going to have to really sell, right, to these legacy aerospace companies.
Randall online
Mhm.
has a question. He said, how has inflation impacted the supply chain, especially fixed price contracts?
Okay, so so inflation is everywhere. And aerospace is not any different than any other industry, where if you are a big player, you can exert your force and, you know, keep the price or keep the inflation low. But in general, prices have gone up, and when you're in these kind of projects, like big flagship projects and programs, when you're working with governments, it's easier to convince the government of inflation. And so we can adjust the cost, whether they either give us some more money and so on and so forth. So if we're in a program and we're saying, hey, you know, we have overrun this month because of inflation of all of these products and so on and so forth, then that's easier to explain to a customer like the government. If your customer is another private industry who their main purpose is profit, then, you know, it's going to be a harder sell. But everybody out there does understand that everything does cost more, and that they understand that if you can prove to them that it is due to inflation, that they're open to that discussion of either paying extra for it or giving you leeway, right, in terms of your cost management. Does that answer your question?
Yeah, I think Randall always has some microphone issue. It happened before.
Okay.
He cannot speak out, even though he was enabled. So I think folks online and here, I think you are here. Oh, I think this. Oh, she says thank you. Randall
Okay.
says thank you. I think you are here. You have interest in the supply chain. So why don't you, speak out your interest and what you might be looking for, or something Dennis can answer. It's better you tell us, and then if and Dennis maybe next time can even tell us more about it. So it will be great. You can tell us who you are or what you might be interested, and see what Dennis can. This is a great opportunity. Dennis is very knowledgeable. So it's good to tell Dennis or tell us, what you might be looking like opportunity. Are you looking for like opportunity in this area supply chain, or your specific question about some technology in supply chain, or like security issue, or things that you're concerned, or things you want to know. And because Dennis gave it the very top level, but it's better rely on you to tell Dennis, what your specific interests. They can better address your concern or needs.
So I will add one. I know some people here are trying to get into the aerospace world of supply chain, and so I'll give you some information. Supply chain is just a top level word. If you're really looking for positions within the aerospace world, there's a lot of different terminologies. Maybe you look at like hardware management, planning, logistics, like look at these different words. A lot of people don't usually use supply chain. They might use supply chain at like the top level, buyer level. But if you start looking at, the next level down, such as delivery from a warehouse to the floor, they have different word terminologies for what they classify those positions as. So if you look for those, you might find positions you never thought was even available. Right?
Actually, on that note, on the enablement side, in your experience, are there like supply chain managers, analysts, that kind of internal group that's sort of looking to oversee all of it, or is it typically that fiefdom thing in the aerospace side?
So the aerospace world, there's always been a historical back and forth of there's a fiefdom, somebody comes in, breaks it apart, then many fiefdoms, crop up, and then they all reconsolidate into one large fiefdom. But most companies in the aerospace world generally has one overall arching, quote unquote, supply chain / buyers group, right? And they are really the face of the company to the external world, right? So you place your order in with that group, and then they will place the order with the external company or the contracts with your customer, so on and so forth. So they're kind of like the external face. Internally, there's different groups within there, such as like manufacturing or integration, or even a different production area. Like let's just say a different product line group may have their own supply, quote unquote, supply chain people that they may be called, supply analysts, or they call hardware management people, or planning people, or logistics people. And so they might have their own little group. And so part of what we did in the when I was building that factory was to look at all these different organizations and say, okay, these 15 groups tier under one executive, and each one of these groups has a similar function in there, saying planning group, right? And that planning group has one person, and that's probably only 20% of their job. So why don't we combine them all together and create one bigger group, right? That manages all 15 versus 20% job, 10% job here, and so on and so forth. And so that's part of the issue, is that goes back to a more of a culture, within each company of, do you want to create your own fiefdom, or do you want to be efficient, right? And so that really boils down to culture. And as I've seen previously before, is that a lot of the culture gets broken when there either is a reorganization or something massive happens, meaning massive failure, or customer comes in and goes, I'm going to shut you guys down because I don't like what you did to me, right? Only do those happen where they really do a quick reorganization. Yeah. But there are always going to be little mini fiefdoms and big overarching group. One of the issues that actually we didn't talk about in the presentation, but it's going to be very relevant from an internal standpoint. And we run into this all the time, and this is a huge problem for us, where as the designer or the program manager, if you need a part, say I need it 6 months from now or a year from now. Well, you give it to your planning group. They have a process that says, I have 2 months to get to your request. Then they submit it to the buyer within your company, and the buyer goes, I have 4 months to submit your request, right, within my process, so I'm not violating my process. And then they have to bid it out. They have to get the bids. They have to review the bids. So you've lost another 2 months, right? And then they have to build it or deliver it. So you lost even more time. And so what happens is that we have to sit here and think back 6 months to a year ahead of time, because everybody has their own little process in place, right? So that they don't violate their process and get in trouble. And so a lot of the end of the line people, like I'm one of those end of the line people, where I'm sitting here like, okay, 7 people, each person has so many months to get to my request, plus delivery time, plus manufacturing time, plus whatever. I got to add that up and go, I have to order this 3 years ahead of time. Right? And something that far ahead of time, a lot of things are going to happen. It's going to get forgotten about, and so on and so forth. And so that's one of the issues that needs to be addressed. So SAP is one of those systems that has tried to address it, but it doesn't address the root cause, right? Because an SAP system, they'll just say, hey, I have 2 weeks or a month to get to it. And so you're right back to the same issue, right? It didn't really solve your problem. Everybody has a specific time to address your needs, and you got to add that all on top of your actual need on the floor, right? And so and then on top of that, if you're not a big player with that company you're buying it from, you're adding additional risk that the program has to deal with. So there's a lot of different things that goes on with, internally within the aerospace world. And part of that is because, we are not building 600 cars a month, right? We're building 1 or 2. So even when in a CubeSat world, we're not even literally as many as SpaceX is cranking out from a production standpoint, like cars or automotives or anything else. It's not even really that much, right? From a quantity standpoint. So we will always get to the, just wait, I'll get to you, right? And even internally, let's just say you're on an integration side and you're like, I need 16 more of these fasteners, and there's no more fasteners, but there's the manufacturing side that uses hundreds of these fasteners every single day. Even internally, you get relegated down from a priority standpoint, right? Because they've got to get their bigger customers because they don't want to get yelled at. And so then they put their bigger customers ahead of you, right? And then when you're behind your schedule, then your senior leadership executives come and yell at them, and then they put you back up on top until somebody else yells at them and they get relegated back down. So it's this, up, down, up, down, up, down scenario of really who has the bigger stick. And so a lot of these companies now, and I'll say Northrop they're starting to realize is that it doesn't do the company as a whole any good to say who has the bigger stick wins the battle. And so they're trying to transition, and we introduced a program management software where it's top level and it's purely based on schedule need, and not that I want to buy down my risk of not having it on time, even though you don't need it yet. And so then they squirrel it away in their own stockpile when somebody else absolutely needs it, right? They don't need it for 6 months. And so they're trying to change that, where a lot of programs do that by buying down their schedule risk by squirreling all this stuff away. And I need it now, and I need it now, I need it now. They take it. And then the other companies or other programs that really needs it don't have it, right? And then so then we get into these problems where, okay, we got to go negotiate with this other program to get it from them and promise to pay them back. And so then you're adding in all these, extra negotiations and document transfers that isn't really necessary, right? So there's a lot of things going on internally, but I think a lot of these companies are starting to realize that you can't function efficiently by doing that. And so they're looking at, okay, how can we get one overall system in place where all the executives are going to buy in on it, saying, yes, I agree with the system, I'm confident with the system, we will work with the system, and then you'll get the parts when you need to. And it's based on actual facts and not so much, hey, I'm not comfortable with that date, so I want it earlier, sit in my warehouse for 6 months.
This is more like a discussion. Do you want to sit down?
No, I'm good. I understand. Yeah, it's okay.
Any question? I would say if you have any interest, please express out opportunities, things, career things. I have several questions, but you can please express your interest and main concern. For example, I see there's a gentleman here, Randall. He asked, what measures do you take to prevent parts from banned countries being used by third-tier suppliers in or doing business in foreign countries?
Okay, so this is a two-part. So part of it is that the government, one part is the government regulates some of it. The other part is up to whoever the buyer is going to be. right? So I'm going to talk about the buyer part of it, where we look at a specific company. If we've never dealt with them before, we're going to look at the company. We're going to do a background, essentially a background check. So if this is a brand new company, what they're going to have to do is they're going to have to submit information to your company to be a approved vendor / supplier. And so that information that's on there is going to be, you know, your background, who you are, what do you produce, you know, where do you produce this stuff, and, you know, all this kind of stuff. In addition to that, it requires on-site inspection, right? Where do you build this? We want to see that, you know, you're not lying to us, right? We want to know where your factory is, where you're buying this stuff from. So we tried to go back as far as possible to have them be an approved vendor, but you're absolutely right that there could be loopholes in there, where if you're buying like a really small part, it could go through 6 other companies, like essentially being laundered, 6 other companies, and that final part and the originator of that part could be in some country that's, you know, that's banned, right? And so we try to be as vigilant as possible with documentation, on-site inspections, continual inspections with our vendors. So if we find out that you are providing bad parts to us, either inferior quality parts, or you're using parts from a banned organization and or company, then, you know, that's where you take the risk of, when we find out, that you get blacklisted to never work with us again. In addition to that, that gets reported to the government, who is a big customer, and you get blacklisted from there. And so essentially you're out of the industry almost, right? And so that's a risk that they run by doing that. So it's generally in their best interest to not do those kind of things, because if it's very hard to get into the aerospace world, but once you do, it is a bit of a cash cow, right? If you have a good product, but it's also very easy to get kicked out. And so that's the penalty, plus, you know, everybody trying to do their due diligence of following up with that particular vendor. I give you an example. This was non-flight hardware, but we had a particular builder up in Montana, and they were building some support frames for us for flight vehicles. So a flight vehicle is going to sit on it. So it was somewhat critical for us to ensure that they had the capability, and, you know, who they were working with, and whether or not, you know, they can actually build what we needed to. So we were a bit of a time frame. So I sent my people up to Montana in December. So let's suffice it to say, they didn't like me for a couple months after that. They got stuck in a snowstorm. But regardless of that, right, we sent an engineer up there. We sent a couple of engineers up there to look at their facility, how they do stuff, you know, how they design the work, how they manage their work. We also sent a vendor inspector out there, you know, to look at all of their supply chain and everything that's required, and they had to submit all the paperwork to us. And it took about 4 to 5 months for approval. That's just for an internal, you know, not internal, but a domestic, you know, within the US company. So if you're an external, then, you know, it becomes a lot harder, right? And it takes a lot longer. But there are gates involved that they have to pass to try to filter out and weed out these people who are, you know, supplying substandard or inferior products to us. Like I said, it's such a big system that there's always going to be loopholes that we're going to be trying to plug left and right.
So Randall, does it answer your question? Well, if you have more questions, welcome to type. Oh, he says thank you.
Okay.
So, thank you. So, so I immediately have two quick questions, and we are entering the discussion session. So I'm trying to kind of help people. For example, we have a gentleman online, Mr. Shimatsu. He has a company here in Torrance for robotic, and he's doing things. I'm not 100% sure, but he doesn't speak out, but I'm just guessing if he's, say, for example, he provides certain parts for robots, it could be supplied to to aerospace company for JPL. How does he get into product to get interest? Is there some way he can register and become a supplier, or if he is needing some qualified parts, as the aerospace quality, and he needs some part, then where could he look and find the connection and find those parts?
Okay.
Just for example.
Okay.
Mr. Shimaki, if you want to speak out, you just unmute. I'm just guessing and try to say something for you.
So I'll answer your question first. So there's a number of different questions within that one question. The first one is, how do you get involved into the aerospace world? Depends on your product, right? If you have a flight product, a non-flight product, right? Robotics could be either or, right? Depending on the mission that you need. So depending on which way you go, there's different avenues that you can go with, right? I'll talk with non-flight first. Non-flight, of course, you got to have a product. And there's a number of different ways. Is you can go to the government website and get approved as a government supply vendor. That's one of the steps. The second one is that you actually have to go to the company and say, hey, I got a particular product for you, and try to get approved as a vendor with them, because each company is going to have their own system as to quote unquote put you as an approved vendor so that they can actually buy from your company, right? From a flight standard, you have to do those things, but in addition to that, there's a lot of qualifications that you have to pass, right? Such as, number one is, and also the mission that if you want to be able to supply parts to classified programs or sensitive programs, then again, right, you need to understand what's going in there. Nothing can be Wi-Fi, nothing can be Bluetooth, nothing can be, all these kind of things, right, that can transmit information. Make sure it's not, you're not having parts from, like I said, a foreign country that isn't allowed. The second part is that you have to ensure that your products, quote unquote, are space qualified. All right. And what I mean by that is that there's a lot of rigorous testing, because when you're up in space, there's radiation, all this kind of stuff that you generally don't see down here on Earth. And so you have to make sure your products are radiation hardened, or can be radiation hardened, depending on what orbit you're in, lower Earth, higher Earth, and so on and so forth. You get different radiation levels, and depending on your mission, right? If you're a military communication, then you have to be, extremely hardened against radiation. If you're just a commercial, then not so much. So, you have to be able to do all those things. Part of the qualification as well from a space qualification standpoint is the materials that you use in there. Certain materials are banned, like zinc plated, tin plated, these kind of things, because out in space, when you get in a hot and cold environment, it tends to whisker, right? And when it whiskers, it touches another circuit, and boom, you have a short circuit. And so you have to be able to meet those requirements and relook at your product. If you already have a product with those things in there to get space qualified, you might need to remove it and redesign it, right? Another could be as simple as maybe the cables that are in there, the sleeve of your cable, if it's plastic. The plastic could be outgas, right? It could outgas. And so you have to make sure that the products that you are delivering to the aerospace world, space in general for outgassing, is that you have to make sure that you have outgassed that product, right? And that it's qualified for space. We've actually had a product come in where we were suspect. This is where we had a little breakdown in our supply chain. We had this harness cable come in, and we weren't sure whether or not it was space qualified. That was a big issue. So we took that cable, took it into our thermal vacuum chamber, and we baked it out. And that cable outgassed so much that it contaminated our chamber. We had to bake the chamber out 24/7 for a week to clean the chamber, because the plastic sleeve in there outgassed so much, right? And so that's why when you're talking about space qualification products, you have to be very careful in the type of materials you use. Has it been tested properly? Because that outgassing from that plastic sleeve could have, if you had an optic on your vehicle, could have stuck all on top of that optic, and then your mission is done, or you have reduced mission capacity, right?
Yeah, so, yeah, I mean, you can imagine, obviously, there are people very interested in how do they get into, say, JPL as a mission, and they are needing some parts, and they must have been announced somewhere, they need some suppliers, and you need to get your product qualified, either cuts, as you said,
Yes.
cuts, or some special thing, and they can, I think it's called the sourcing or something.
Yes, it's sourcing. So
To be among their radar.
yeah,
So they can see whether it's cuts or something they can.
so there's two parts to that part. Number one is to get into whichever company you're trying to get into, whether it's Boeing, Northrop, JPL, and be part of their approved vendors, right? That way they have a approved vendors list that, people who are doing proposals or suppliers can go to and say, here are our approved vendors. You can work with them. The second part is almost like your reputation in the industry. If you provide a good part, but you're not in the industry, in their approved vendor list, you can approach and say, hey, right? Or the engineers who are designing this vehicle will say, hey, we need to buy the product from them, but they're not part of our sourcing group, right? Of approved vendors. So they'll send their sourcers and supply chain people, go get them approved. We need their product, right? So there's really going to be two parts to that is, do you have a product that they want and need? And the second part is getting into that company's approved vendor list.
Yeah, for example, the aero environment, they are making the switchblade, which should be used a lot in Ukraine. And because of the situation in Ukraine, there are more demand, and they were sending the Bradley, vehicles, and certainly there's other more demand, but in order for the system in Boeing, as you just said, they might have a different system in air environment. So each company might have their specific, vendor, preferred vendor.
Correct.
But if you have a good reputation generally in industry, you might get some referral.
Yes, that is correct. So there's a number of different ways you can go onto the government, U.S. government website, and apply to be an approved vendor to U.S. government contracts. That's another way. Like I said, you can go to specific companies and say, hey, I have products, space qualified products, and if you have a good reputation, they'll probably add you in there. You just have to go through their process, and inspections and so on and so forth, to be part of their vendor list. So there's multiple different ways, but just like anything else, you have to have a good product, number one. Number two is that you have to be able to know the industry to be able to give your product out there, which is like trade shows and so on and so forth, where a lot of these companies come to these trade shows and they show off their products. And I've been to a lot of these trade shows where, the first thing I asked them is, where's your company based out of, right? Not to bash any foreign country, but as soon as they say China, I have to walk away, right? I just can't, no matter how good the product is, I just can't, it won't be approved, right? And so that's the first thing. Where is it based on? Where is it manufactured at? What's it called here? And so at these trade shows, it's a lot of where you get your products kind of known out there, because a lot of the industry does go to them. Unless I said you're that good and you are the only few that make this particular product where everybody already knows you anyways, right? Then it becomes easier to get, part of their approved vendor list.
Yeah, I agree. Actually, our intention is gradually, hopefully we can put up some vendor show, then how else we can get some kind of vendor, have a table, some here, as you said. And another way, like a previous like space conference, now Ascend, they have this trade show. And I've been to this SMC, the Air Force, they have, it's kind of, they have project, they have contract, and then they have a workshop, and they're several vendor. you can have the booth there. That's
Right.
another thing. And I also noticed, because I've been to San Diego a couple of times, the Navy also sometimes come up with some kind of, they post it public, if you're interested, you can give a show or something.
Yes,
Yeah,
that's
so-
correct.
Yeah, we might be able to compile some of the public information, not top secret thing.
Right.
For our
Right.
attendee. But this is actually related to, sorry, if anybody have any question, because I think I'm probably asking the question you might want to ask. This is similar issue the other way. For example, if people want to, actually, we have member or people that try to look into jobs, put it in country for supply chain contract, and we do see people like they are VP or people that are buyers in companies. So what would you suggest for people outside the aerospace industry, or they are students, they want to interest in this? What kind of training, degree or courses that will help them to and of course, our goal is eventually to get people to come to our meetings and network with the people working supply chain in the company to mutually, this is related to the previous question, but how can one prepare themselves to be ready? Say they might be in supply chain, other industry, or they are student and
Sure.
interested in this, and do they have, which generally in company, what will they look into? Say certain degree, or the student takes certain courses, or some kind of certificate or training.
Okay, so a number of questions there. So the first one is the fantastic thing about supply chain is it's been around forever. So there's many universities that provide, degrees on supply chains, which is fantastic, right? So, you can go to any one of those if you're really into supply chain and get a specific degree in supply chain. So from a educational standpoint, I think it's very easy to get into that profession. If you want to get into a specific profession, let's just say you want to get into supply chain in the aerospace world, it's great to have that background. But one of the other backgrounds that's good to have, it's not necessary to have, is something like this where you understand how the system works, right? And so when you understand how the system works, you can be better trained, of what job you need to do. Because supply chain in retail world at Walmart is, as you can see, is not even close to how we deal with, our supply chain here. And so you have to be able to at least have an idea of how the aerospace world works, how the government works, because in aerospace, it's pretty much going to be government contracts. So a lot of that information is also available online. I'm like, when I worked with the Navy as a contractor, they had courses internally on supply chain auditing, and so even the government and NASA and all that, they have their own education systems devoted to these specific professions like supply chain, right? Because they're teaching specific things that their group needs, right? That's not the same as any other industries. So that's most definitely another way. In terms of how do you get into the industry, it's very subjective. It depends on what group you're in, what company you're in, and who's hiring you. I can only speak for myself. When I managed one of the supply chain departments, my philosophy is I'm not necessarily too concerned with your educational background. I want to see who you are, right? Do you want to do this? Do you understand what's being asked of you? Are you excited to do this, right? I can teach you the rest, right? Because anything specific in an industry, you're not going to learn in school. They're going to give you the basics, right? Everything else you're going to have to learn. So as long as you're excited, you want to do the job, and you can show that you're going to be a team player and work with them, then I think it's going to be, in my view, it'll be very easy to get supply chain positions. Supply chain positions is going to be a lot, I would say, in aerospace world, it's going to be a lot easier to get into because supply chain isn't going to require like a particular STEM degree, like if you're trying to go for engineering or something like that. So it'll be easier to get into from a supply chain standpoint. So for me, as long as you understand what you want, what you're getting into, and that you're excited about it, in my view, I can teach you the rest as long as you're willing to learn, right? And it's easy to get there. I give you an example. I used to do, what did it call it? It wasn't recruiting, but maybe it was recruiting. A lot of these companies, they have coordination and job opportunities with the military. And so I would travel to certain, location and bases. I went to one in Hawaii, and there's a lot of people there because they have clearances that we need. So I went over there, and I was talking to this one kid, and he goes, I don't know, I don't have many job skills. I said, well, before we start with that, why don't you tell me what you did first, right? What did you do in the military? He goes, well, I didn't do much. I go, well, humor me. What did you do? He goes, well, I was responsible for 600 people. I had to make sure they got on the plane, got their equipment, they got to the right location, this and that. And I'm sitting there like, wow, you do a lot more than most of our supply chain people do. I go, what do you mean you don't have any skills? Right? I go, how long have you been doing this? 8 years? I was like, well, let's reevaluate that, right? And so I explained to him, he goes, I love what I do. I love the coordination and all this kind of stuff. That's fantastic. There is skills there, right? And what you're doing right there is phenomenal, getting 600 people to the right place and none of them getting lost with their equipment too, right? And bringing them back and so on and so forth. And so, I was working with him to say, hey, you may not have the degree, but boy, do you have the experience and you have the excitement of wanting to be in this industry. That's all that's really needed, right? People, a lot of people nowadays is shifting away from, if you don't have a degree, I won't even look at you, because people are starting to realize that that's not necessarily the case, because most of these engineering companies, and I've seen it firsthand managing so many departments in there, is that I would say a good 1/3 of your people has grown up through the ranks from a technician and never had an engineering degree, but now they're in engineering positions because of experience, right? And so there's no reason why we can't apply that same reasoning to external people, right? Because if you had somebody that's worked 30 years at, say, Boeing, and they want to come over to Northrop, and they don't have a degree, but they've been doing the job for 30 years, why would you discount them just because of that, right? And so a lot of people are starting to realize, that's not necessarily the smartest thing to do. And so they're really looking at your experience, your background, your excitement, and whether or not you really even want to be in this industry. And so there's going to be there's starting to be a fundamental shift. And I would say a lot of it started with SpaceX, and them saying, I don't care about your degree, it's really about your experience. And then you can see companies like Google and Facebook, they're saying, hey, you don't need an engineering degree. You graduate Google University, we'll put you in one of our companies. And so you're starting to see that gradual shift and fundamental change from degree or nothing to degree or experience, right? So it makes it a lot easier for people to get into different industries now, or even not even specific industries, but maybe to a different group within the same company, right? For example, if you've worked in supply chain in a particular company for 10, 15 years and you know everything inside and out, it's easy for you to jump to another internal group, to do maybe something similar, but not the exact, and start to learn new skills, right? You start to build your skill set that way. So there's many different opportunities now that a lot of people are more open to than previous years or decades, per se.
Yeah. So if you have any question, welcome to speak out. But this supply chain is very important for public policy and career workforce development. So each year, AIAA members get to go to Capitol Hills. We have congressional visit days. So we organize members go there to talk to representatives, senators on important aerospace policy issues. But it's not to lobby for any specific company, it's a general agenda. So if, say, next year we AIAA go to, and AIAA also train you if you go to visit, they train you and how to talk to the representative. So if you have one specific topic and you want to tell the congressman or congresswoman or senator about supply chain, manufacturing, those kind of things, what is the one thing you want them to know? And when setting up policies, is there some important issue that need to be fixed or improved?
Yeah, in my view, I would say it's red tape. I mean, most like anything else. And here's my experience why I say that is that I understand what the government is doing when they create a lot of these policies, such as if you bid for this program, so many of your suppliers have to be veteran-owned, have to be women-owned, I'm all for that, don't get me wrong. But then when they come back and they say that your budget is constrained to this level, but you're putting all of these requirements on me, I don't know if I can meet that, right? I have to go to some of these vendors that I buy a lot from because they give me a bulk buy discount. Right? But if I go to these smaller companies who can't make a profit without charging me more for, and I have to use them, right? And so they're going to have to look at that balancing act of what is actually required versus, what their ultimate goal is going to be. Because I know we've had our hands tied very often by those kind of requirements. In my view, that experience that we have.
I hope we can go with us next year to Capitol. Any question?
Hello. I have a question.
Yes.
I'm recently joined industry like this space industry. I came from like medical equipment, and which are the more mass production, a lot of volume. And my question is like a detail about like manufacturing, like assembly line, especially like a technician. So like mass production, it's a lot of product and a lot of each documents. It's easier to train the technicians so that they can easily to skill up and to continuously produce. But how in the space industry, like it's very niche and production volume is low. Sometimes it's just one production. So the technician, how to train technician might be difficult. So like how to select the good technician, how to train. I think there is like a unique way in the space industry. So I want to hear about like how to train technician, how to organize, manage, like especially in the space industry, in this like low volume in the production.
Okay. So you're right. It is a niche industry. There isn't going to be any kind of educational institute that's really going to teach you these kind of things. And so what you see in a lot of these companies is that it's a diverse background of who's working there. We have a lot of people from the automotive world, that's worked in here. I've had people from just work at BMW and Toyota, and had their own shops. And one of the key aspects that we looked for was their flexibility. Do they understand that you're going into a different industry? Are they adaptable? Learn something new, but also retain their skill sets? And how do you apply those skill sets to this new industry? So we're looking for flexibility, we're looking for adaptability, and we're looking for general excitement of being in this world. Because when you're in this world, you're, for example, in the space industry, If you work in a clean room environment, you're going to be working in a, a full-on bunny suit for, I don't know, 12, 13 hours. And it's going to be completely different than sitting in a shop, in your regular clothes where, you have more freedom of movement. So as long as they understand what that is, that's going to be another criteria. From an internal standpoint of how do we select a good technician on the floor, there's going to be some personality traits that we really look for. Because this is a niche industry and because the products that they're working on is extremely high valuable and also could be extremely dangerous, we are looking for people who have leadership skills, and we are looking for people who also understand a macro point of view and not just a micro point of view. And what I say by that is they're not just focused on, I'm here just to do this one particular job and that's all I'm going to do. But what you do affects the person in front and potentially behind as well. And so we want somebody who's able to look at what I'm doing is a big system. I'm part of a big system. So that what I do affects the next person. I want to make sure that the next person's job is easy as possible. So we want a person who's able to work in a micro world and also in a macro world, right? And that goes back to the part of the leadership as well, because they're making big decisions. They could be working on a product, like installing a fastener bolt, and that product could be $10, or they could be working on a crane lifting a $100 million payload, right? And so we want people to be able to shift around. And what we generally do is, if a person is not yet quite there, we have what we call kind of quote unquote training programs, where we start people off on the floor, seeing the operation, but they're doing lower level tasks. And so we slowly move them up until we're comfortable with them, operating, say, a crane where we're lifting the entire space vehicle, which is worth hundreds of millions of dollars, if not billions, right? And those are only reserved for our most senior guys, right? The more junior ones who we're training would maybe work on the panels and, prep the panels and start working their way up on the floor. So it's kind of like an informal on-the-job training until we're comfortable with both their skill and also their personality and leadership skills to be able to give them larger and larger roles within the manufacturing and integration world. And then eventually, one of the top things that our technicians do that I'm not sure, in any other industries do, is that because we are such a niche world, and there's very few people that do the job, and it's very high profile, is that a lot of times our customers love to be on the floor. They like to see the product, they like to talk to the people. And so this comes into where, the technicians have to be able to comfortably communicate with one another. Not only just one another, but they're going to have to be able to communicate with engineers, senior management, and our customer and or government officials. And so there's a big communication aspect to it. And this is part of the reason why that most aerospace technicians and factory workers generally get paid more than other industries because of these demands that we place on them that most other production facilities do not have. Did I answer your question?
Yes, thank you very much.
Yes.
Actually, Mr. Shimizu, because Takuro, the gentleman who asked you this question, working with Mr. Shimizu, the company is called Gitai in Torrance.
Okay.
Doing robotic. Hopefully, next time they can have the trade show with us. I've been trying to get Mr. Shimizu to let us know more about it.
I mean, I'd be happy to talk more, offline or separately with you guys.
He was in our event in February for this startup training, or UCLA has a Bridges.
Oh, okay.
Yeah, and he was there
Okay,
in
perfect.
person, so hopefully we can get more involved. So Mr. Shimizu, if you want Takuro to say a few words about your company, go ahead. But before that, any question here?
I have one.
Yeah.
For someone starting, you touched on that before with supply chain. Is there one area you recommend that one, like more of an insight, either procurement, logistics, planning, that you recommend someone starting to get their foot in the door?
I would say that it depends on your personality and what you want to do.
Okay.
Right? There are certain people that love to sit in the office and deal with customers all day long. And so they're probably better suited to be on the buyer side, doing the paperwork, calling customers and so on and so forth. Then there's other people who, like me, don't like to sit in front of a computer 24/7. I like to be down on the floor and moving around. And so there's other groups like the planning or the logistics groups where you're getting parts from the warehouse and or suppliers, and you're storing them, and you're managing the paperwork and then delivering them to the guys on the floor. So it really depends on your personality of what you really want to do. Because if you're a guy that likes to move around and do a little bit of everything, getting stuck in your office all day long is probably not going to be ideal for you.
Yeah, I agree.
But I think it's going to be equally easy to enter any one of those positions. Now, granted, the positions where you're on the floor and running things, they probably would like to have a little bit more experience in the aerospace world. But if they like you and you're willing to learn and you have some background experience, that's a job that can be easily trainable. And we've trained many people from many different industries and some don't even have a background in the supply chain.
Oh, so you mentioned this internal thing. Actually, I can tell you, I feel this supply chain is a very interesting thing. It's everywhere. It's hard to grasp. It's not like engineering. You know exactly what it is to work on. This is kind of everywhere. Then you have Takuro just asked about the technician thing, but it could be all very high level. For example, recently there's a news, Lockheed Martin and Northrop Grumman expressed COI for having a company in Germany called Rheinmetall to make a fuselage for F-35. Initially, I couldn't. I asked some of the senior members, and they said COI is not actually a contract. It's kind of just intention. We plan in the future we might get a Rheinmetall from Germany, which is one of our allies, to make important parts of F-35.
Yes.
So it's
Dangling a carrot in front
it's
of the
very
trade
high
agreement.
level. It's not like a buyer can decide,
Yes.
or something like that. Then versus like Elon Musk, I think it's shifting his whole. I don't know about SpaceX, but for Tesla, he used lithium-ion battery, and which China is a big supplier. Now he's trying to shift away from China, and he can basically make a decision which company he want to use.
That's correct.
But Lockheed and also Grumman, they have to do it very carefully. First, say something about the inches, and then get some kind of clearance, and to have the Rheinmetall become the supplier.
That's
And
correct.
So how would you comment, the top-down process to add the supplier versus like bottom-up, some engineer, or buyer, they think, hey, this company from certain area, they could be our ally, they are our ally from some place, and there might be some controversial discussion. Germany, you will think, yeah, they are our ally, and they bought F-35. Why is an issue that why this company cannot be making the fuselage right away?
So I'll talk about the two. So two questions there, from top down, bottom up. From a top down perspective, I would say 50% of it's going to be political, right? Dangling the carrot to our allies, say, hey, or some of that, you want me to buy 135 F-35s, then some of it needs to be built in our country, right? just like some parts were built in Turkey. And then when Turkey and the US was having a spat, right? When they were having a spat, there was talk about pulling the production out of there and bringing it back to the US. Because at that point we were concerned about the continual supply, right? And so there's going to be a political aspect to that at the very top of, is it because of trade agreements? Is it because I'm dangling a carrot to get something, or is it that country say I'm not going to buy your product unless some of that work happens here, right? So there's a big political aspect to that. So that one's going to be harder to break into, right, from a corporate standpoint, unless you're a huge company, like the Boeings and Northrop and Lockheed's of the world. Unless you're like that big, it's going to be very hard to break in from the top down. If you talk from bottom up is going to be more technical based, right? An engineer is going to come up and say, hey, I love this product, and they're going to ask why, and it's really going to be superior product, it's the only person that makes it, or whatever the reason is going to be. So if you're going from bottom up, you better have a technically superior product where you're probably one of the few that makes it, so that you would have visibility into a company's supply chain. So there's two different ways to approach this. Top down is going to be easier because it's mandated by the government, it's going to be mandated by the customer, it's going to be mandated to you on the contract. Bottom up, on the other hand, is you're going to have to convince all these people that this is the right product to use, right? And so it's going to be much harder from bottom up from that standpoint. So there's pros and cons of both ways of how you look at it.
Actually, you mentioned this because recently I also read an interesting report about I think it's Swedish, right, or Norway. I think it's Swedish, the Gripen, right, the fighter jet. And they have the upgrade version of Gripen, and they are talking about some issue. They lost a contract. They did lost the sales to several important sales, and they have a big contract for Brazilian government, but they lost several in Eastern Europe. Yes, at least I heard that maybe some deal with Hungary. But one important issue was that a lot of parts, supply chain for the Gripen was from other countries, especially from United States.
Mm-hmm.
And when the United States stopped supporting the engine to the Gripen, and that caused a lot of concern from the buyers. They say, hey, wait a second, this is not all made by Swedish, companies. And then, as you just said, the Turkish has, I think the drones has the issue, and the message just pull back, the parts. So supply chain is obviously very important. So it's very important subject actually. I don't think this is actually a question because there's a Brighton case actually. There's a supply chain actually affect the sale,
Right.
Because other countries were concerned whether Sweden would be able to supply the products as promised.
Yes. Yes.
So, I'm just trying to say actually supply chain is a very important issue, but it's kind of very vague. There's no specific shade. It's kind of everywhere.
That's correct. It's a very complicated system. There's many different levels. If you're talking about supply chain, like you're talking about at a governmental level, it's all politics based, trade agreements. That's going to be 50,000 feet above our levels here, right? If you're talking further down where you're actually on a project and you're buying products and materials, and that's more controllable, within your realm of expertise and authority, where you're able to influence the buyer and which vendor you want to go to and so on and so forth. And versus if you're a company and you're trying to get into a specific industry, you're working from kind of almost from the side. You're trying to hit the top level, being an approved vendor. You're trying to go to these trade shows. You're trying to meet people and so on and so forth. So you can see, and then internally, like we talked about, there's many different levels internally of what supply chain is. And so supply chain is just one big behemoth, and it's just a matter of how you really, cut it down to size and which part you really want to talk about, right? Because each group is going to be different. they'll tell you, for example, too, in a program, there's proposals that we talk about upfront design. In a proposal world, you're going to look at, okay, we talked about supplier capability, their quality of the product, their, whether or not it's technically better than others. But then, we have workups of all of our decision makers, right? Meaning who's our customer, who's our suppliers, and we have complete profile workups on everybody. What do they like to see? What is it, and we try to appeal to their good senses that they love to see, right? And so our supply chain is sometimes, I guess, remodified to kind of win programs, whether or not it's necessarily the best thing to do going forward, but if it's the thing to win, then that's sometimes how we change our supply chain, at least at the top proposal level, just to win something, right? Next level down, then you start really looking at the technical feasibility. Is it really, and less the political to win the program, right? And then further down, you get more and more technical as you kind of go down, right? Proposals, there's a lot of talk about, hey, yes, we have this, but everything's wonderful, but we all know when you get into, your preliminary design and, CDRs and all these kind of things, everything changes. Almost everything's out the door except the base requirements, right? And so each level has their own pros and cons and different ways of handling supply chain. That's just internally within a company and a program, right? And so each industry will be different too, as well, than what you're trying to do.
Yeah, I think that's a great idea. You just mentioned something. Maybe occasionally you get like a trade show or focus on, as you say, how to win, how do you say, the contract procurement process. Maybe, next time or in the future, kind of pick up some subject, because as you say, it's very wide. And maybe, like what you said, and what you said, how to winning the bid, how to winning the project, and how to what the procurement process. And actually, as I just explained earlier, AIAA is it's a nonprofit official organization, so it's not lobbying for a specific company. So I say for public policy wise, AIAA is actually very good for general, like what you said, red tape thing. And actually, AIAA might have some influence on this, CBD, and get attention to the leadership. A lot of our leadership, they are very big. For example, our executive director, Mr. Dan Bacher, he was a former NASA manager on DCX project. So he has a lot of connection to NASA, and we have some leadership in the aerospace company. For example, May 11th, we'll have annual awards dinner. And this year we decided to give our Excellence Award to Aerojet Rocketdyne. And we have the Senior Vice President, Mr. Jim Mazur. He's going to be there, and he is actually also being elected to our honorary fellow this year. So, by the way, the reason why I mentioned it is because we have people that can, in general, not specific company, but general policy, but also it's a connection. You might be able to meet people that is, have for top down, and they meet the grassroots people. And another reason I mentioned that because Aerojet Rocketdyne is a supplier for Optimus project. They have the like RS-25 engine and some other engine, so they are also considered supplier. And initially, I was actually talking to Dennis was that actually we can use something as example. The drone thing I mentioned, supply chain, a switchblade or some other thing could be a topic, or Optimus. Actually, I noticed a lot of companies, not a lot, several companies in Southern California, they are, if you go on NASA website, the supply chain, they actually show general, like aerospace corporation. I don't know exactly what kind of product or just a service they provide.
So it's funny that you brought that up. That is one of the prime examples of the rocket engines when we lost the capability to build our own and we relied on Russian rocket engines, right? We stopped the space shuttle and we had to rely on the Soyuz rocket. So when the space shuttle stopped, it went from a $25 million flight overnight to 59. No reason, other than we could, right? And so that's something to think about when you do these kind of things from an international supplier, and so on and so forth, is that there are ramifications for some of the decisions. You may not see it right there and then, but you're going to be paying for it for generations down the line, right? And that's why like Blue Origin had to come onto play to build a new rocket engines to replace all of the ones that we're buying from Russia, and so on and so forth, right? Because we no longer have that capability and we don't want to be reliant on them, which is a good thing now, right? So you need to be a little bit cognizant, like I said, the international portion of it as well.
Yeah, and of course, Blue Origin, Elon Musk. And Brendo has a question, but I just want to say something about, you just mentioned this Russian technology rocket. Another one is the radiothermal, the battery, the radiothermal energy, the engine. That's another example of plutonium, things, uranium. Well, probably we should wrap up, but Randall has a question. What are the key considerations if there is a need to surge production from a supply chain point of view, going from LRP to full production, or just increasing production on existing line, 10x? Let me see if I can pull the question on screen. Can you see it there?
Okay, so what are the considerations if there's a need to surge production from a supply chain point of view? Okay, so this is going to be part of the upfront planning. If you don't plan correctly, and that includes surge, reduction, and so on and so forth, and or quote unquote issues along the line, then you're going to fail. So when we talk about surge here, it's not something that it's like it's unplanned. Oh my gosh, somebody came in with a brand new order. Generally in the aerospace world, it doesn't, that's generally not how it works, right? It goes through contracts and all that kind of stuff, so you have some time to prepare. But generally, what we do when we have to do a surge is that there are spares involved. If there are spares, then we start utilizing those spares, or we start taking parts from other organizations or groups within the company that has the same parts and is qualified, and then essentially what we call pay them back. We place another order immediately to start paying them back if we didn't plan ahead of time, right? And so there's a number of different ways to do it. Borrowing it from other programs and paying them back is one way. Another way to do is that they plan ahead where there's a potential for a surge. If the program management did it properly, then they would either buy extra stock and have it on hand as needed, or they work with the supplier to say, hey, what is your capability to support surge production? And if they say, well, we always have so much on stock, we're able to give it to you and turn around within an hour, no problem, then we don't need to buy it. You guys hold on to it. When we need it, you'll get it here within an hour, fantastic. So there's a number of different ways to handle this kind of scenario. It depends on the product that you're building and how well the program management, did their job in managing the program and supply chains.
Randall, does that answer your question? Oh, he said thank you. Very good. So any more questions here or online? So if not, Dennis, you have things you want to say to wrap it up, or?
Oh, yeah, sure. So yeah, I want to thank everybody for coming by and asking these, fantastic questions. I know we talked about a number of subjects beyond supply chain, like how do we find, good technicians, and I guess that's more of a leadership thing that we can talk about, later. How do we find good people? But again, thank you very much for coming by and listening to the subject. I'm assuming everybody had a good interest. Not many people like supply chain, so thank you for coming by. Appreciate it.
don't leave yet. So here is the certificate appreciation.
Oh, thank you.
So Dennis, great support. So take a picture. Thank you, thank you.
Got a couple.
Thank you, thank you.
All right, thanks.
Thank you, thank you.
Thank you very much.
Thank you.
So you're welcome to, we have to leave by 2, but if you want to stay around network, you're welcome. So if any question about AIAA, let me know. Supply chain or leadership thing, you can chat with Dennis or you can network with each other. And online folks, if you want to speak out, you're welcome. So, but by that, we'll start the recording now and we can conclude the session for today. So stay in touch. We'll keep working with Dennis on this and the leadership and other interesting subjects. Thank you so much. Have a good day. Bye-bye.